so we could probably plot it every 10. All right, so let's look at the graphing calculator now and how we can access all this. All right, so first let's do a of x, 15.7 times 0.98 to the x. Let's go to our grapher. Let's type that in. All right, so if you want to look at the graph, you can, right? If you want to take a look at what this thing should look like, it gives you a little taste, right? From 16 to 40, right? All right, first thing, look at your graph that's provided. Your graph goes from 0 to 100 on the x and 0 to 20 on the y's. We can make the calculator look like that. All right, it doesn't have to go in auto mode and go from 16 to 40 and 4 to 12. We can make it look like the graph you were provided. So how do I customize that's what you're doing. You're going to customize your x and y axes. You can go up to axes now, not auto, but go over to axes if you want to customize it. All right, let's do the values of x first. All right, I don't want auto. I want to go right here to minimum. So the minimum we want is what? 0 all the way to 100. So I go 0 to 100, confirm that bad boy. All right, now we want to do the y-axis as well. So we go to the y-axis. And now on the y is what? 0 to 20. All right, 0 to 20, confirm. All right, so it looks like on the x's, I'm going 0 to 100. On the y's, 0 to 20, confirm. And up should pop the screen you're looking at. All right. So our first graph should look something similar to that. But again, are we just going to go and you guys are better than this, right? We're not going to go, oh, it looks good. You're not going to do that. Absolutely not. That's embarrassing. I'm not even going to claim you as my student if you do that. All right, absolutely not. So how can I find points to actually graph now? Now I go back. Everyone sees table up above. So we go to table. Okay, this is what, is a little bit different than your graphing calculator. You have 0 on there, correct? Or maybe some of you guys have something different. All right, I start with 0. I guess you can scroll. Nope. See how yours goes 0 to 10? Or does anybody else something different there? Because mine only goes to 10, and that's going to be a problem because I got to do it out to 100. All right, that's going to be a problem. So what we can do is go up above and do the set the interval. All right, set the interval. And now you can tell it where to start. Not only this, you can tell it where to start, end, and what you want it to go by. So you don't have to go 100 times to get to see what it is at 100. Do that again. Yep, 100 times. So go by tens. All right, go by tens. Confirm. And now you can look at that bad boy right there. It's going by tens. So it makes it very easy now to graph this quicker. All right, much quicker. All right, so I'll let you guys do your best. Graph it up to 100. So anytime you wanted to set the interval, you can on the table. Anytime you want to customize your axes, you're able to. And you can't leave for 2 hours. Put your best work in now, right now. Put your best work in. Remember, this is a 6-pointer. Last point before we go to the next curve. It says graph it from 0 to 100, nothing more than 100. So don't go past this. Don't put an arrow on it. It's asking from 0 to 100, including those values. So do not go past it. No arrows on here. 0 to 100. That's awful, but we're good. And now we can go to B of X, B of T, B of X, sorry. Now you can go to B of X. For this problem, it's great because the interval stays the same. But we go on to a new graphing problem down the road, we're going to have to change our table back because this is what it's going to stay in for anything you graph going forward. All right, it won't go back to original settings because you turned the calculator off. And there's one last thing we got to talk about after you're done graphing. Final thing, anybody know?
You gotta label what colors, what equation.
I got to at least label one of them so I can say which one's which. All right, you can do both, but I at least need one labeled. So, you write A of X up here or B of X, that's fine. All right, but at least need one labeled. Yes, anytime you have two graphs on one axis, you need to label them. Yes.
Can I go print the other one?
Can I finish this one?
Yeah.
All right. Everyone good here? Good on those new features of the graphing section of your calculator. All right, now you tell me how to do the next one. When are these two equal to each other? Yep, where they intersect. So how do I get there? There's a couple different ways I could do this. All right, go ahead.
Put them both in your calculator in the graph part and then see where they intersect.
Okay, ready? There's another way we'll talk about. Yep. So I go back. If you want to put both equations in there now, there is another way to do it, which I'll go over after we're done this way. But I definitely want to show you this way. So add another equation, which is if you already have the other one deleted, type it back in. Okay, graph. Yep, so you got both there. Now you have a calculate screen. Okay, calculate. You can calculate a ton here. So let's go up to calculate. You can pick either one. We'll pick the first one and see where it says find. calculate, find. There's a lot of things you can find, right? You can find the max, the min, but what we're looking for is the intersection, and it'll put the darn thing right there on it. All right, now you got to here's what you got to worry about. What are we looking for, the x or the y value here? All right, because which one do I take off here? We're looking for the x value. All right, we're looking for the x value here, which would end up being, and I'll show you why, how I know it's the x value if you're using the graph. So about what, 35? Was anybody going to do this a different way? And this will show you why I need the x values. Well, ready? Here you go. Hey. Let me just write the equations again. When is it equal to? Now it makes sense. I'm solving for x when I set them equal to each other. Where can I go to solve this? Maybe you didn't think of the graph. We're like, all right, where else can I go? Equations. Type it in. Yep. And I'll give you 35. So 2 different ways I could do this. All right, 2 different ways.
You have to show that one.
It doesn't say anything up there about solve the equation algebraically, so no. Nope, and it doesn't look like you need any explanation at all. You can just write x equals 35. And then how about this last part? To the nearest minute, what's b of 100 minus a of 100? Where can I get those values? Graph, or go back to your table, right? Go back to your table. B of 100 and a of 100. Make sure you got the correct numbers.
Wait, should we just round it first?
Write it all out. Round it at the end, right? We round everything at the end, not in between. Even though it wouldn't matter here, but it might. Just check with me up here, make sure we're getting these values for b of 100, a of 100, and then subtract them to the nearest minute, 2 minutes. When you subtract it and round to the nearest minute. Okay, hurry up, let's go. We good? All right, I wanted to show you some new things on the grapher there that you can go to. Yep.
Because we're seeing minutes, like explaining.
Yeah, we're good. Yep. Everyone, anybody we're okay on the grapher. That was my main point. All the different things you can do there. I want to know how much power you have in your hands, but you got to know how to use it. All right, so we're going to the June one now, June 2022. Really, here's what I want to do today. I've been preaching store, use your calculator as much as possible. I want to do these straight up now. All right, if it happened to be on a part 2, 3, or 4, how do I do these problems straight up? All right, we know we can get them. We know we can get them right. We know we can get them right by storing or using our calculator some other way. But how would I do this straight up? So number 1, which expression is equivalent to x to the 3/4? Yes, store number in for x, find the value, see which multiple choice matches that value. We get it. I want you to do that a week from today. All right, I want you to do that. How do I do this straight up? How do I turn this into radical form? How do we do this? Okay, so I got a radical with an x underneath. How the heck do I remember where the 3 and the 4 go? Exponent, right? It's exponent over the index. Exponent over the index. So it would be x to the third with an index of 4. Okay, e over I. Exponent over index. Do you have a question on any of the other multiple choices up here? Okay, go to number 3 now. Go to number 3, everybody. Number 3. Yes, store again, right? Store in a number for x. What the value is, good to go. But how do I do this straight up? I'm dividing by x plus 3. So you have 2 options. Probably the first option is not a no-go, and I understand long division. All right, where you get the little do your long division. No, probably. Instead, you probably want to go the quicker way, which I do, which would be synthetic division. I don't know. Maybe they'll have you do it on the part 2. Who knows? All right, what am I dividing by? X plus 3. So in synthetic division, I put the opposite in, or what the answer would be, which is -3. This is a tough exam. They're going to throw a lot of traps at you. Just like right now. There is no trap here, but it could be. Now I start putting the numbers out in front, the coefficients, right? 2, 7, -3, -25. And watch for that trap. All exponents have to be represented, right? Hey, pretend this wasn't here and it just went -3x. I got to put a 0 in there. All right. All exponents 3, 2, 1 are all represented. All right. You ready? Synthetic division. What comes first?
Bring down the 2.
Drop the 2. Then do what with it? Multiply it by -3. So I get -6. So combine them. 1. Multiply again. They don't cancel. They give you, yep, positive 18 here and -7. And that is called your remainder. So if you were to write this final answer out now, if you were to write it out, I always start with 1 less than the biggest exponent at the beginning, which was 3. So now this is going to be an x squared. So 2x squared. And now it goes down now. Plus 1x minus 6. And now remember how we wrote our remainder. -7, but over what you divide by, which is x plus 3. There it is. A little quick synthetic division. Yep. Okay, I'd expect you to store, but I want to do these straight up. I'll get back to I'll put that back up later. I want to keep moving on though. Okay, 7. Yep, we know. Go to equations, we know. But how do I do this straight up? Eventually it's going to be a log, right? Because the variable's in the exponent, but not right now. All right, again, when is it time to use the log? When the base and exponent are all by itself. I have a 5 attached right there. So I have to get rid of the 5. Divide both sides by 5. So I get e to the x plus 2 equals 7/5. I don't know if that's a pretty decimal or not, but I'm just going to leave it 7/5. Base, exponent are by itself. Now you can log. All right, how's this log thing work, by the way? How's this work here? What's the next step going to look like? Everyone says it's log, 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 which you are correct, but what's the deal now?
Well, you bring down the x plus 2 in front.
X plus 2 in front. Now I do the log of that base. So take a look. That's what that looks like. I bring it down in front. And to keep it balanced, log the other side, the 7/5. And make sure we know here, because I kind of have it look like the twos. These are being multiplied, right? They're being multiplied here. All right, what moves over? You got to get x by itself. What would be your next move? Divide by log e. Yes, I don't want to divide by 2 log e because they're separated. So yep, divide by log e. And then you'll have x plus 2 equals a crazy decimal. I know that you're going to write all out, even if your wrist hurts. I don't know, whatever that is. And then what's your final step? -2. Okay, and that'll give you an answer which matches one of these answers when you type it in. But yes, I know, I would expect you to go write 2 equations, find the answer, and then figure out which one matches that. But we got to know how to do this stuff straight up.
Wait. Can you just tell me the answer
Sure.
so that I know if I did it right?
Number 7.
Like, I don't know what.
Whatever choice 1 comes out to be. I didn't write the answer myself, but it's choice 1.
Like the decimal.
Yeah. And so if you do -2 plus ln of 7/5, whatever that decimal is, that's what the answer is to that one. What do you got, Martin?
I don't understand.
You got to put it to the first.
Oh,
You got to. It's
always, like, every time.
unless it's to the x or to another number, but yeah, because you can't delete it. That's the one drawback here. You can't delete that exponent. What do you got, Paige?
I'm confused. I didn't get, like, I got a long decimal when I figured it out. Like, I didn't get that number one.
Which matches that long decimal.
Oh,
Your answer to this should match when you type that in. So whatever decimal you got so when you do log of 7/5 divided by log e, subtract 2, you're going to get a nice long decimal in your calculator. And then if you type in choice 1, you're going to get the same, hopefully the same decimal out. Sorry, I can do it too. So log, everyone good? We're getting that, -1.66. Okay, everybody good? We're all good here? All right, 12, getting ready for tomorrow. You can't really do this on your calculator anyway, so we're going to have to do this by hand either way. So as I go from 2 to 4 on each one, we got to compare their rate of changes. Okay, so as I go from 2 to 4 on each graph, let's look at their rate of changes. All right, I'm going to go g of x first on the graph, the one that's provided. All right, and I'm going to find the rate of change. What's on the bottom? 4 minus 2 or 2 minus 4, doesn't matter. Okay, 4 minus 2. How do I find the y values?
The table.
Not on this one. I'm doing g of x now. G of x, not t of x. I'm doing g of x. So I got to go to the graph over here, right? At 4, what's my y value? 1, 2, 3, 4. It's going to be this one right here. I don't know what is that one. Yep, 10. Minus, what is it at 2? Should be 6. Everyone all right on how we're finding those? Because again, how are you going to find the y? There's 1 of 3 ways you're going to find the y values and rate of change. Table, graph, equation. Okay, in this case, it's a graph and the table. So we're looking at a 2 here for the rate of change. All right, now let's go t of x. How to find the rate of change for t of x. What goes on the bottom? Trick question, 4 minus 2 again. But now you're getting the y values off the table.
Do you have to graph, like,
So when
3.
x is 4, we got a 3 for y. When x is 2, we got a minus a negative 5. Be careful, make sure you don't put minus 5, minus a negative 5. So this rate of change is 8. And now we answer the question.
No, it's 8 over
Relax,
2.
8 over 2,
Yeah.
4, yeah, I got it. It's come up on every exam. Along with 13. It's come up on every exam. Directrix y equals 3, vertex. You don't even have to do the equation like you're going to have to do tomorrow. It just needs to know where the focus is. Scrap graph attached at the end of your exam. 2, 1. There's the vertex. Let's see, where's the... there's the directrix. It's a line. Okay, how are these 3 related? Where's the focus going to be?
2 away from
Vertex is halfway in between, right? So there is what here? 2 units. So your focus should also be 2 units away. So our focus is going to be at 2, negative 1. Yep. Vertex is halfway in between. All right, I got one last one here with you, number 20. Anything? It is. But
it's max.
how about just graphing it?
Well, that doesn't.
Well, all right. Well, how about we just graph it and take a look? All right, take a look here. Let's go. Let's go. Make sure you're in radian mode. You want your calculator to be in radian mode unless you absolutely need degrees, but I don't know when that'll happen. So I go to graph it. Be careful though. Remember, you're still in all your. Might have to change our everything here. We'll see. All right, 5 sine pi over 6. And then what do I have? Another parenthesis rocket in here. T x minus 5. Close that all those up. And then what do I have on the outside? Plus 7. That's good. Okay, remember it's still on the axes from the first problem we did today. So if you want to go, you can go to auto. That'll fit it into your screen at least. All right, ready? Low tide occurred at 2 a.m. Let's see where it is at 2. Oh, right on 2, right? What?
My calculator says no valid function is turned on.
We have it all typed in. But you were able to graph the first one?
Yeah, oh my God.
Well, that's because you have a T and a Y. You gotta keep it X. Keep it X because it's only gonna graph an X. Okay, because that just thinks it's some random number. So X. Okay, keep it an X. Okay, are you going through these choices here? Seeing which one's gonna be false? It's easy when the graph is up there. All right, it's easy when the graph is up there for you. What about 9 a.m.? So 9 a.m. it's about 11, approximately 11. Yep. So the only one that doesn't work is choice 4, right? The difference in the depth from it's 10, not 14. All right. Don't forget about grapher. I know you guys love to go to equations so quickly. All right, and start typing stuff in, but grapher will help you out a lot too. All right, so you got your quiz tomorrow, 12 questions, and here's the ones I'm looking at for tonight if you want to try them out to keep on pace. If not, hey, good luck to you. You got to get that. I know 26, 28, and 30 points seems, it's going to be so easy. It's also going to be embarrassing if you can't get there, right? But if you put in the work, you don't have an issue.